Now I'm going to demonstrate to you how we can perform the PET sample t-test using IBM SPSS. So in this example, we measured the diastolic blood pressure before the examination and after the examination. Okay, so we want to compare the diastolic blood pressure before and after the exam, okay, among students. So first of all, we need to check for the normality of the data. I'm not going to repeat it again because we have done this many times, so you can refer to my previous video. So I'm going to analyze straight away the PET sample t-test. So analyze, you go to compare means, you go to PET sample t-test, right? So here you can see PET variables, variable 1, variable 2. It doesn't really matter which one is variable 1 and variable 2. So just transfer one diastolic blood pressure to one slot and another to the other slot. Okay, then you can click option if you want to change the confidence interval, but I'm not encouraging you to change, so maintain at 95% confidence interval. So then you click OK. So this is the result for the PET sample t-test. So as you can see, the mean for the diastolic blood pressure before the medication, or we just say that this is before exam, so was 105.07 plus minus 3.955. The diastolic blood pressure after the medication or after the examination was 87.07 plus minus 4.7, 4.6, 4.70, something like that. So we want to know whether the reduction was significant, right? So look at automatically the PET sample correlation will be computed. They will compute the correlation, but this is not going to be very useful for us at this moment of time. So we check the PET sample t-test table. So you can see that the mean, the significant value here is 0.000. So because it's 0.000, that means it's way lower than 0.05. So we can conclude that there is a significant reduction in diastolic blood pressure before and after, okay, after the medication or after the exam, when compared to that of before the exam or before the medication. But because the value here is 0.000, the way that you should write it in your paper should be P less than 0.001. So why we put 0.001? Because if we report as P less than 0.05, this is going to be underrepresented because it's way below than that. But if we say that it's 0.000, so we are implying that there is no avenue that analysis was actually incorrect. So there is no possibility that the different what we call conclusion can be made. So because of that, we put number 1 at the end of 0.001, so that it gives some probability that it is still possible, but according to the data that we are having, so we rejected the hypothesis. So this is how we can perform the PET sample t-test.